So I'm David Gesswein. I'm giving a talk on how to use SimH. The slides for this talk will be posted at that URL there. When I put them up there, I found out the way they look nice, all the hyperlinks in them don't work. So if you go to the text mode by clicking on that little button on the slide, then the hyperlinks will work, but of course it then lose the few graphics I put in. I also have little pieces of paper here with that information, so you don't actually have to try to write it down or take a picture of it.
How did you create the slides?
These are LibreOffice, different,
Export as PDF doesn't preserve the hyperlinks?
You can, but that's one big PDF document, which, they had a way that it still looks sort of like a slideshow that you could randomly easily go through. So, I need to go see what is the best way to put it on. But yes, you can export the PDF. I may end up doing that if I can't figure out how to get them to work right. But for now, that will work for you. But after VCF, I'll look at it a little bit more and go get the latest version and see whether they fixed it. So, I use SimH, mainly the PDP-8 emulator, but played some of the other ones, and done more research on it for this talk. So this is what I plan to go through. What is SimH? History. What machines does it simulate? Why use simulators at all? And installation and general usage information. And since this was sort of been part of the Unix thread at this VCF, I'll show you how to run a couple different Unixes under it. And some other things people have done with SimH. So, SimH is a framework for writing simulators and a collection of simulators for various computers and their peripherals. It is mostly text-based. Some simulators do support graphical output if the machine they were supporting did have a graphical display, but not every machine will support, or not every simulator will support the graphic displays that were on that machine. Depends on the implementer on whether they did that. And historically, graphics has been more of a portability problem, so the graphics capability has been growing more, more recently, and some of the old historical ones tend to have less graphics. It runs under Unix, Linux, Windows OS 2, and VMS, and it is still growing with a number of contributors to the code base. SimH started in 1993 when Larry Stewart of DEC Research noticed that the computing past was being lost and suggested to Bob Supnick to do something about it. So then that's when he started SimH. The initial targets were DEC PDP-8, PDP-11, and Data General Nova, which is sort of interesting since that was one of the competitors to DEC. With the internet, it moved from one-person sort of hobby thing to a collaborative effort. And in 2005, there were about 18 architectures simulated. We have 4 of them done other than by Bob Supnick. Currently, there are about 36 architectures simulated, and I counted about 55 binaries when I made the thing. Since some of the architectures support different models, and sometimes they do it by generating a different binary. Sometimes you do it by a command to set the mode when you run the emulator. So here's just my summary of the machines that are simulated and some random things I could find about them. So, it simulates, a lot of different sizes and ages of machines. 1959 to 1984. Some of the Hewlett Packards. Were still sold into the 2000s. So some of the notable ones, the 516. Honeywell 516 was the computer used in the Internet Message Processor, which was the first interface between ARPANET and the computers. Yep. It also had the first fork implementation, and it also was the kitchen computer, which was Neiman Marcus's annual catalog, had expensive, weird gifts in it, and one of the years was that computer, which was supposed to be used in your kitchen for doing recipes, but the computer was like, it's in my notes, but I don't remember exactly how much, a ridiculous amount, 10,000 or something, and it only had a front panel. There was no teletype or any other interface, so you had to get your recipes in lights and toggle in on switches. It came with a 2-week training course. As far as anybody can tell, none of them were actually sold, although the Computer History Museum does have one that matches the style of it that I saw online. So I don't know whether they have used that style for something else or that was just created for it. What else?
So I really, really, really hope SimH comes with a disk image for the kitchen computer.
I don't think that comes with it. Actually, in general, there's some images that were part of the earlier SimH, but the simulator is not necessarily also doing the images to run under them. So you end up sort of having to search around for some of them, which I'll get into a little bit. But especially when Bob Supnick was doing it, he was trying to recover DEC software, so he did retrieve a bunch of DEC software to make usable images. But for some of these other machines, there is no other than possible. Sometimes there's little diagnostic or demo things that are part of it, but full images to run operating systems may not be part of SimH. And feel free to ask questions. I think I have plenty of time. It's always hard to tell how many slides you should create. So some more. And IBM had a whole bunch of weird machines, and like they have the 700, 7000, which you would think would be a family, but they're more of a common technology and sharing peripherals. But each target market had its own instruction set and its own data representation, so they're not even anywhere near compatible. The early computers is definitely interesting. And the first 32-bit Unix port was to the Interdata. I don't remember which one of those two models. Yes?
The Intel stuff, I recognize those as multi-bus boards, if you weren't sure.
I wasn't quite sure what year they were, which is the question mark.
Oh,
Normally I put a year down, but I wasn't quite sure.
70s. I think the first multi-bus was like 76.
Mm-hmm. What else do we got? So the Libroscope, the LGP30, was the computer that the, quote, butterfly effect, this also goes by a different names of chaos theory or sensitivity to additional conditions, where he was doing weather modeling on it.
Wow.
And he had actually done something that changed slightly the input data, and then when he reran it, after it projected forward in time, he got an entirely different forecast. So people didn't realize that things could be that sensitive to the exact initial state and more unstable in propagating forward. And that also is the classic story of Mel. On these early computers, frequently you need to do all sorts of tricks to get either decent performance or even fit your program in the constraints of these machines. So that was, his employer had wanted him to write a blackjack program for demonstration. and put a cheat that they could throw a switch to make the customer win. But he ended up putting it in so if you threw the switch, the customer would always lose. So that the next person they asked to fix the program was so impressed by all the things he did in the code, where he ended a loop by the data field overflowed into the instruction field, so it made a different instruction, which then allowed it to terminate the loop. So that person said, "No, I can't fix it for you." What else? So the DEC PDP-1 and the TX0, which is a similar machine, had a lot of firsts. What was it called? Expensive typewriter, expensive desk calculator. Got the other couple other things. But yeah, I had some notes that I can't get to pull up right here, so.
Read the book.
Yeah.
Read Hackers.
Ken
Yeah.
Olson built the 600 at Lincoln Laboratory, where he worked after going to MIT, and it was designed for testing core memory. And they gave it to, when Lincoln was done with it, they gave it to MIT Model Railroad Club, and that's where it comes in with the book Hackers, starting out that book.
But yeah, both that and this were then individual people got to sit down and actually use a computer instead of submitting your program to be run by the mysterious people behind the glass. So that's where a lot of early development on interactive computing occurred. And then of course we got the PDP-7, which is the first Unix platform. And then the PDP-11, which was the second platform. 780 VAX, which was the basis for your MIPS of instructions for benchmarking for a while. And Alpha, which is started the trend to optimizing for high clock speeds, and RISC and other people were also doing that sort of at the same time. Let's see. Okay, and the last notable one is the SDS 940. There was the Douglas Engelbert's online system, which was the mother of all demos, where he demonstrated
Mouse and
the mouse, collaborative document editing, teleconferencing. There's a whole bunch of things that you would not associate with 1966 that he demonstrated in this demo. And there's a nice video of it online, which I probably should put a link to, but I don't think it's in there currently. This computer was also used for, I always put first in quotes because you always get argued with, but that's what online claimed. The computer memory, which was the first, they claimed, bulletin board system, which was, I think, with Berkeley. It was in a record store there, and you had to pay to post, but you could read for free. And I think the computer ended up going to a couple different locations. And those were also used by Timeshare, which was a sell computer time service. The early version of the cloud. I guess the Sigma series, one of those was the first node on the ARPANET. Kind of pointless until the second node came along. So, why use simulators? You can't. Not currently for sale. We'll buy it now on eBay. You can't plug it into your outlets.
You can afford the electricity.
So I think this is an IBM 7090. And also some other interesting things people have used it for is to make the PIDP8 and PIDP11, which is a straight production of the front panel on them with a Raspberry Pi inside running SimH to actually make it act like the real computer. There's one over in the Computer Museum.
We've got
See it?
one over at our display.
Oh, okay. So they're nice looking machines, and there's also the Blinking Drone project, which either animates real panels. It's a lot of, the machine was scrapped and somebody kept the front panel for nostalgia, which now you can at least make it look like it's a working machine. And it also has, for that project, also has GUI to display it on the monitor. You don't actually have a front panel. For me personally, I use it in combination with actual hardware. So some of the debugging is easier under SimH because you can more easily put breakpoints and poke at things, get instruction trace history. When it stops and says, how did it get there? You can just go look at the instruction trace and see. I really prefer modern editors over line editors. It's easy to back up and restore when you make a mistake and wipe out your disk image. And saves time when you're trying to get ready for VCF. And at times I find nostalgia is best in moderation.
And SimH on like a Pi 3 is running, what, 20x faster than
Yeah.
a real 8. So, and if you run it on an Intel, what, 50, 60 times faster than...
Yeah, it's ridiculously well faster than a real machine. But the real machines, at least if you have like an RK05 with a PDP-8, it's actually not that bad performance-wise in itself because you didn't really do big things on it. But it's, you know, mainly the editors were not great. And it also allowed me to, like, I have these dump and restore tools to allow people to archive media they have and rewrite it onto media. So I was able to create that for some peripherals I didn't actually own. Like that. Okay, so how to get, that's bizarre. So on my monitor over here, those first two are blue. It looks like that's sort of bluish. Okay, for my angle, there's almost no difference between the
It's a binary projector.
So, but those are the hyperlinks I was talking about. So instead of putting long URLs in here, I put in the description and they're hyperlinks to the actual thing.
So if we click on this, that screen on the wall,
You got it.
touch screen?
So, you go. SimH. Did I miss a slide? Yeah, SimH was originally done by Bob Subnick, but it's been transferred to Mark.
He's 3 slides here.
Okay, I must have skipped some bullets that I meant to read.
That was the last bullet.
Okay, yeah, so it's now hosted on GitHub and a new primary maintainer. So that's basically a link to the GitHub repository. And there are Windows binaries on that site too, so you don't have to build it yourself under Windows. SimH has not been doing official releases while it's been under GitHub. So everybody just uses the master branch.
It's a very important point. But they're trying to find some original ones that I've been studying. So,
If you're trying to find older official releases of SimH, they are on Bob Supnick's site. He has the back history, but it's tucked away in a spot that's a little hard to find. But they are up there. Since there are no official releases, most the distributions for Linux and BSD variants do not track the GitHub, so the versions they have are pretty out of date. So it's best under those to just rebuild your own. with Git, you can either use the Git commands, or for people who don't want to learn yet another tool, it just lets you download a zip file of the current source. So you can do either method. And there's some links to instructions on then how to build it. It does support Ethernet, which if you want it to support Ethernet, there are some extra hoops which are with those instructions. It has a built-in NAT capability, which you can use. It may be the easiest, but it only works with IP-type networking. It will not work with things like DECnet. And ICMP messages aren't supported, so you won't be able to ping across the NAT. And then there's live PCAP or VDE2. I use live PCAP for the stuff I build. And for if you're wanting to have the graphical capability, you need to make sure you have the right graphics libraries installed when you do the build. So if you have issues with trying to use it, it does have an issue tracker, and there is a mailing list for it also. And the first thing you'll be asked if you post to that saying I'm having problems is what version are you running, and when you report you're using some ancient old version, you'll be next told get the current source and try it again, and if it reproduces, then we'll deal with it. They're not hostile, but they don't want to troubleshoot things that they fixed long ago. So now I'm going to move on to Unix simulator, SimH simulators. So the first Unix was implemented on a PDP-7. There are no known pictures of the actual machine that was used. So this is a representative PDP-7. The machine did have a display, but probably was not using a little scope like that, since it was some fancy custom graphics hardware that AT&T, it was, this was a machine that was used by some visualization, whatever group there, that they were declared an obsolete sort of machine, and it was pushed off into the corner, so they appropriated it for their own uses once the Multics effort got out of the Multics effort, so they were wanting to see what they could do to have some sort of similar environment on something they could get hold of. This machine does have deck tapes. The Unix does not show any support for the deck tapes, but so they may or may not have been present on that machine. The PDP-7 was configured with 8K 18-bit words of memory and an RB09 Burroughs fixed head disk drive with 512,000 words per surface. Only one of the two surfaces in Unix. The other was used for backup. And it did have the custom graphics to display for a visual and acoustic research department. The only thing they used it for was for the text display, so it could put up 538 characters, then you would get a page full button, you would push the light, you would clear it, and display the next set of characters. The simulator does not simulate fully that behavior. It just has it acting more as like a normal console. It maps it to inside SimH. This is TMXR, which is its interface to Telnet. So you can map serial ports to Telnet ports, and that's what they're doing there. For the Unix, partial source for this version, it was recovered from an old listing. The shell is a recreation, since the listing did not contain the source for the shell. I was unable to determine how accurate the replacement necessarily is to the original. And the link there has the Unix source code and instructions. You either have just a binary image of the disk drive you can use, or it actually has all the source, and they have tools so you can actually build it. So, the way you run it, you execute the PDP-7 simulator, and the second parameter is a file that contains SimH commands, and then you should get a login prompt, and then you can log it as can, password can, or DMR, password DMR. These are not real accounts, there's not real content. All they had was a listing, so this is just what the person who did the recovery felt like baking and putting in there. And that Unix v0.simh defines the simulator configuration and bootstraps the computer. So this is just showing what you'll get. I'll actually do this live if everything behaves itself in a second. So this is the config file that's with it. So we're setting the CPU to have 8K of memory. I don't remember what the maximum memory is on a PDP-7. It's expected somewhere like 32K words. We turn on the extended arithmetic element, which is some extra math instructions. The CPU history is just for a debugging tool. It keeps the last 100 instructions executed, so whenever you halt, you can go back and see what the last 100 instructions were. And show CPU just shows you what the configuration is. We're configuring the console teletype input port to have the right translations for Unix. We're turning on the RB09 fixed head disk and attaching a file to it with the contents. We're enabling the graphics tube and attaching that to a telnet port. And we're turning off some hardware that it doesn't know how to deal with. And we're loading boot.rin is a paper tape image in read-in mode format. So we're loading it at address 10,000 octal, and then we started executing.
You want to share, Dave?
We'll see. Thank you. Yeah, that one I went to root with a minus, so it cleared the path. Let's do this again. This one doesn't need to be root. When you do the networking, it needs to run as root. You're going to see how well I can type. Okay. So that it was a fixed head disk, so those are a little snappier. Probably takes a little longer though. So under here, there's actually, let me do this. The first time you do it, you need to do this weird link. Since it's already been done once, the ls defaults to dot as what you're doing ls on, and some other things do. But if you create a hard link of dot to whatever you want it to really point to, it doesn't seem to have real paths. You can't do slash, not name slash name. It's kind of bizarre. And this also shows the really impressive error message you get. I've already created the link. Then it doesn't work the second time you do it with the D question mark error. So, can't be. So you can see that it does simulate some of the delays you would get on a real teletype. It does not seem to exactly match the delays. And that's the other interesting thing. That file doesn't exist. No, you know, I could tell you that you just tried to compile a file that doesn't exist. I'll just cite the complete.
Put your cat out, hello.base, and see the source code.
The BCPL.
Is the assembly file text readable, or is that binary?
I think it's readable.
Yes.
I can. I'm not doing well today. I'm a little slower. Wasn't that impressive?
So the right, I take it, is limited to 2 characters then, right?
I have not done enough research to understand what the real limitations are. So
that is in.
I am not quite sure what that's in.
This will probably be bytecode.
Pseudocode?
It's not
The bytecode that.
Well,
it's
It's just mnemonic, I mean, it's not even,
Well,
it's symbolic, it's not even.
right, okay, so B bytecode assembly.
But yeah, actually understanding that was probably a little farther than I needed to go for a talk on SimH. And actually what to do.
The address function, address, memory addresses.
So when you come into this, the telnet interface, it doesn't have any displays, so that comes up pretty much so immediately.
Does who work?
No.
You're not running 2 copies, that is multi-user that you showed us, right?
Yes.
Oh.
So it's 2 users. You have the graphics display and the teletype port. I think is all it supports.
Right, it's not telling it, it's serial.
Oh, good. Good. Yeah.
Does it emulate a clock? I mean, is there like a date command in this that you can show us? Or?
I don't think there was a date on this. Let's see. Yeah, there does not appear to be any timestamp with the ls-l. And what was your question?
Yeah, I just want to say that I worked with Warren Toomey on the PDP-7 Unix, and so any of the questions regarding the decompiler on that I can address.
Okay, so
Is this the source listing? It's like, it was like found in somebody's attic or something, a box?
I'm not sure where the source came from for the PDP-7 stuff, but it was just a printout that they kind of retyped back in. And, yeah, working again.
Norman Wilson.
Yeah.
Norman Wilson had an old printout.
And then the V compiler that you ran there was like a recreation that I did by looking at the old C compiler source
Mhm.
and kind of backing out the V compiler. But we had the bytecode interpreter and a couple example programs to work from, so to make that possible.
Is the bytecode stack based?
Yes, it does have a stack. It grows upward, and, but it's a very inefficient compiler. It's not like the interpreter. It's not like the one that was on the TV7 or 11, which is the threaded interpreter. This was a very limited interpreter, and even the B language was like a subset of the B language that we used on the TV11. So very, very rudimentary.
Well, getting that kernel to boot again was a really cool example of digital resurrection.
But yeah,
Cool work.
one of the hyperlinks does give more information on where that source code came from. I understand it. Which one of the original Unix people passed not that long ago? Yeah, so I understand it was like Richie had found the listing, somebody else had made a copy of it, and then when Richie passed, his original copy got lost. Nobody knows what happened to it, but then they found the other person had a copy of it, and that was what was used for the restoration. Okay. And to get back to the command prompt is Control E, and then we can just do quit. And speak up if you have questions. I'm ignoring you. I admit I'm not always the best at paying attention to all the audience. So,
Is there a build? You said go to GitHub and get the code and build it yourself. Is there a build environment or is it just source files?
for the Unix set,
No, for the SimH.
The source is designed to build under the particular environments I said. Unix-like systems, VMS. It said it supported OS2, and there were a couple other oddball ones. And then there's, you can build it under Windows, but sometimes that's a little more difficult.
So if you've never done building before, how hard is that? Is it like?
Call somebody to help you.
Yeah, it is.
It depends. It depends on, they're pre-built binaries for Windows. So if you run Windows, then
No, I've never had a big one.
right. It's not that bad to build it. It depends. If you're needing Ethernet support, then it's a little more work. But it's for building the basic stuff. It's more or less just type make on your distribution, and it will probably work. It'll complain about, I can't find this, so I'm not going to build graphics. I can't find this, so I won't include Ethernet support. And to activate those, you need to go use your distributions command to install the right development libraries for those functions. It's not horrible, but if you've never built before, you're not going to get it working in a half an hour necessarily. But
Either call somebody or do something that's very well documented, like build Apache or something like that. No, but you'll find lots of directions for that, and then you'll get
there is a reasonable amount of directions, but the problem is the directions tend to get out of date because the next version of whatever distribution, they decided to rename this library to a new name, so the command to install it no longer works right because the package has been renamed and things like that. $20 minutes left? Okay.
Do you know if there's any work going on to put any of the European computers into the Sim?
There were some in that original list.
There were?
Oh, there were. SSEM. But no, it actually is heavily oriented towards, and we got a Russian one. But no, so it definitely is more weighted to US machines. But there are a couple other things in there. Okay, so next PDP-11 Unix. And this is a real photo. Properly staged, this is not all sorts of stuff piled around. So this was the next host for Unix after PDP-7. PDP-7 was really a pretty limited machine, which limited what they could do with it. So moving to a PDP-11 gave room for the operating system to grow. There are lots of different Unix variants out there with images. So I have a bunch of links to some of them, and you know, search engine is your friend. If you have a particular one you would like to try to play with. I arbitrarily picked 2.11 BSD. For that one, I used a pre-built disk image just to make my life easier getting ready for this talk. But if you want to do it old school, there are tape images, so you can do the process of doing a build from the original distribution tape images. Like I was talking about, things tend to be slightly out of date on the internet. You know, there are a couple things I had to change in the script that was with it to make it work. The first one you may or may not have to change. You know, the name of your Ethernet adapter, if you're trying to enable the Ethernet, varies on machines, so you may or may not need to change that. And the other thing is, without this set CPU auto config, on a PDP-11 for peripheral devices, there's like register space and upper memory for things to talk to them, and then there's an interrupt vector, if I understand correctly, for each device that uses interrupts that need to be configured. And it's assuming that that happens auto-config, but when you do the attach to the DZ specifying manually the parameters, it then stops doing it for any further device. So when I set CPU auto-config back on, then the devices that followed then got properly configured. Okay. So this is to get my laptop to be able to use the networking to the simulator. You can't actually use directly to the Ethernet adapter because due to the way it's internally architected, the packets aren't seen by the simulator from your own machine. It works fine over real cable, but they have this as part tap tunnel interface, and this script configures that. All goes well. Okay, so that configured everything, but hasn't actually started booting. So now we enter the boot command, which it just told you what to enter. And then I think you can put some options in here, but in general you just want to hit return. Now it's come up in single user mode. If you want to go into multi-user mode, you just do a Control D to terminate the single user shell. And I think you also remember one other thing. This image is not happy if it doesn't have a name server. Everything will just sit there for a really annoyingly long timeout before it finally gives up on resolving names. Start a name server. It should.
Have you found any advantages or disadvantages running SimH on a Pi versus under Windows versus under Linux?
There's little performance differences, but no.
But as far as operationally, it doesn't seem to make any difference.
Well, the hardware would be different. The Pi is no serial port.
No, at least I put a serial port on SimH just using a USB adapter hooked up to a power bank.
Oh, okay.
Yeah, I don't know.
And it more or less works.
But yeah, the Raspberry Pi does have the GPIO pin, which is how it works for the blinking bones that allows an interface to talk to other hardware. Okay, so password is root. No, plug in root, no password. No, this looks like a normal Unix pretty much, so. And we should be able to.
When we're in Telnet.
You said I don't need to buy a vowel? I'll blame it on the keyboard.
Okay, so in that window you just had there, are you telnetting into the serial port emulated by SimH, or is that actual networking?
That's an actual network port. Since I did not, on the telnet command, I didn't specify a port. So that's a real telnet to the normal telnet port of the simulated, or of the unit running under the simulator. So,
With that tap in or with that tap.
right. So if you end up set up the right route, this PDP-11 Unix, you can go talk to FTP servers on the real internet if you have all your networking properly configured. I did that at home to verify it really does work, and I managed to find an FTP server that still exists on the internet.
Oh, there's lots of bullet ports.
Mm-hmm. So I don't have anything terribly impressive to actually show with this, but so that gives you two sort of spots in the Unix spectrum.
Is it possible to get a tool chain running in this and actually compile stuff inside this world?
I assume we got it. Yeah.
I did this on some Unix and some PDP-11 a long time ago. It's really
It's
easy.
okay, it doesn't have to be spelled correctly. Actually, we'll believe it really works if it's misspelled.
You can even do things like catch the C compiler halfway through its operation, see the weird internal thing it was using.
Just the link. You have to link it first.
Oh, okay. This one doesn't auto link.
It's there.
Yeah.
Dot slash AR.
Oh,
Dot
okay. Yeah, I thought the older ones didn't, still had dot in your path, since I knew that was sort of back in my misty paths when all the Unix decided to switch from taking dot out of your path.
For fun, run cc with dash capital S. It should spit out the source and the assembly.
And then specifay.
Just tell it
T-
.c,
Or T
No, that's
or whatever you called it. And T.S or maybe, yeah, maybe something like Yeah, there we go.
And I saw it, yes.
TDP-11 assemblies.
You had a question back there? Or?
Yeah. How does this differentiate between running the computer versus the simulator? I'm trying to figure out how the simulator differentiates. Just simulating the architecture.
I'm not that familiar with QEMU. I thought that was for doing emulation of, Intel processor type stuff. Does it do others now?
It can do pretty much any processor.
Okay.
I would say that QEMU is for more modern architecture,
Yeah.
and it's also faster.
Yeah, it's faster, yeah.
SimH is more of just a traditional kind of simulator machine, so it's more maybe accurate, perhaps.
I'm guessing QEMU doesn't have that 48-bit Russian supercomputer.
It is modular, so I guess you could add it.
Yeah, but there are lots of different simulator projects out there. MAME.
Well,
Another big one.
You said something earlier that kind of triggered something.
Yep.
It seems like you may be simulating more than just the CPU.
Yes. Yeah. This simulates normally the.
The QEMU is just the CPU. It doesn't care about anything else.
Yeah, this simulates normally a representative set of peripherals to make the machine useful. Also.
I run the PDP-1 simulator and run Space War on there. You link in a frame buffer into the PDP-1.
Yeah, if I have enough time, I'll show that at the end.
I was just going to say, one thing I read, and I'm not sure exactly how accurate it is, but they apparently would find bugs in the original code with SimH because of the timing differences, since it was the modern computers were so much faster, the timing was different, and so when you start uncovering bugs in the original code, that was dependent on time. It was slower.
Although from a viewpoint back then, I'm not sure they would have considered that a bug because it was written for that machine.
Right. So it's really hard to find.
But there definitely is bugs in that old code. I'll be demoing Marksen's batch on my PDP-8, and I actually had to go fix an error in the source because it wasn't working right for one of the things I wanted to show. Herb, you had a question?
Yeah. You contributed to the PDP-8 code on SimH?
I think I've made a couple minor contributions, but not a huge amount.
When you dive into SimH, Sim code, for example, for PDP-8, is it informative about details of the architecture and hardware and peripherals and all that? Or is it just, you really need to know that going in?
It has some information, but it is not intended for you to learn about the architecture from a PDP-8. The comments are trying to say more of what this is doing in relationship to what a PDP-8 does versus trying to teach you what a PDP-8 does.
And are you pretty happy with the depth of the simulation for the 8?
Yeah, the SimH is taken the practical, so they do not necessarily try to perfectly emulate the original machine. They give you tools you can use to try to make it run about the same speed, but unless there's some program that really cares about it, they're not going to necessarily try to be 100% accurate in timing, and normally they'll give you a mode to run as fast as you can, unless that really just doesn't work with the software that's available for that machine. But for the PDP-8, I normally do not put any sort of throttling in, and it works fine. It doesn't implement all peripherals that's on a PDP-8. It's never perfect, but it's definitely quite useful.
Okay. Is that Warren's version of the code? Which version of the PDP-8 code? Oscar's or Warren's?
This is SimH. SimH.
Oh, okay.
Yeah, he wrote the original PDP-8. You had a question?
Yeah, so I lost how we got to PDP-8 because it shows a PDP-7 and then 11, and then I somewhere got confused. How do we?
My specialty is PDP-8,
Okay.
so that's what I've mostly used in SimH. So that's why we keep drifting back to that. It's not necessarily quite relevant for the Unixy portion because Unix never ran on a PDP-8.
And what software do you run on your 8?
OS8 is the common operating system. I also have this monitor system. And then, I frequently just run standalone with little programs that I'm working on for VCF for demos. 5 minutes? Okay. Let's see where we are. Okay, so, the image has some default networking that's in there. You're probably going to need to change it to match what you want. Yeah, some of that I've already went over while I was running the demo. And here are some more spots you can go look to fully understand how it works. And there's my modified script I use for setting up the tap tunnel. If the script doesn't work, it may mess up your networking, but it does not permanently change any configuration, so a reboot will clear it out. And I have an issue with once you set up that tap tunnel, if I put the machine to sleep and wake it up, it ends up changing the configuration on me. I think that manager is being annoying. And wireless make the networking more complicated. Device handling, simulated disks are normally directly mapped to host files. They can also be attached to physical drives for SimH. Tapes vary, half-inch tapes. There's a SimH format, which is the preferred, but it does know how to use a couple other common formats for half-inch tapes that are used for tape archives. Deck tapes, since they have host machines with 12, 18, and 36 bits, which you then need to store in 8-bit bytes on your host machine. So there are different mappings for different tapes, and it supports several of them. So it does attempt to figure out which mapping the tape uses, but you can manually specify if it doesn't. Paper tape reader and punch map to host files. Serial lines either go to that main console window you started from, or they're mapped to telnet ports. Printers currently just map to a file on the host. Somebody had started some work to be able to create a nice PostScript for formatted thing to actually send to a printer, but never got integrated. And we do have the graphics display. The ROM and non-volatile RAM, you just use the memory load and save commands to simulate. Clocks are tied to real time on your host system. And not all original peripherals will be supported by any particular simulator. The command line, the command language has a lot of capability, which I have not gone into that much detail on. You set CPU throttle to control the CPU speed to make it act more like the speed of a real machine. When you're running these operating systems, SimH will tend to take all your CPU time for its process. The set idle detection for certain operating systems, it can detect when the operating system goes into a busy loop and handle that so it can then stop executing instructions until it needs to again to save CPU time. Sometimes it can be challenging to figure out how you get files in and out of your simulator. For the PDP-8, I tend to use the paper tape reader punch to attach it to a file on the host and use the pip command with -I to bring it in, like OS8. And you can save the simulator state with some commands and then restore them later. And the command language is quite powerful. It has conditionals in it, asserts, it has expect, so you can actually have it look at the output from the simulated machine and take actions when it matches strings in the output if you want to automate stuff. And it also has a built-in multi-level help, so you can do help, command, option type thing, give you the lower level stuff. I think it's sort of like if you ever use VMS, I think it has sort of a similar-ish command help structure. So, you know, yeah, so help show would give you one set of things, and help show CPU would give you a different set of output. And it has debugging tools, so you can set breakpoints, the CPU history, examine and change the CPU and device registers and memory. And if you don't find SimH does what you want, you can always go and modify the source. I've actually done that a couple times when I wanted to trace exactly how this certain thing happened, and I would go add a little bit of prints or whatever in the source to see exactly what I needed to. And it does have a built-in disassembler, at least for some of the simulators, so you can show the memory instructions. And the single stepping mode. Probably looks like I won't get them. I was going to show you, you know, some of the graphical stuff on the PDP-1. I think I'm out of time.
Let's do it. You got 10 minutes till the next person's using the room.
Oh, are they here yet or not?
Yeah, I'm here, but yeah, go ahead.
Okay.
This leads into what I'm going to talk about too, so perfect. Control D, log out.
Text. Yeah. Yeah. I don't know if that one actually has log out too or not.
Maybe halt.
Where'd you want to have
Oh, I was just looking up like, mostly just looking at the history of the C programming language. In fact, if you look at PDP-11 assembly, C suddenly makes perfect sense.
Oh, yeah.
Oh, right. Yeah, of course. And how to PDP-11 assembly, you select the process. So you have kind of stuff with the C for the
Oh,
yeah, of course. Yeah. Yeah, of course, it's the crystal. So, my cynical view of all of computer science and architecture is all we've been trying to do is make PDP a little bit faster.
There's some
So yeah, throttling the CPU does help with the PDP-1. It seems like if the CPU runs at full speed, then it doesn't give enough time for the graphics code to run.
Close the leading door.
Never had a chance to play with
So this is just a very short little set of instructions that generates not really random sequences, but they're sort of random, but they have patterns. So when the number row and then the letters below it are mapped to the switch registers. So if you hit the right switches, you get some interesting patterns.
Yeah, pretty cool. It's about pretty close to that.
Okay.
It seems like it's kind of tricky to emulate.
So this is mapped to like the ASDF keys.
Well, you have gravity set.
Yeah. You just need to move around the sun effect if you actually know what you're doing.
Oh, that's what you persistence.
Okay, so now I should let the next speaker